Hey everybody, this is Mr. Bells here. I'm coming in on this Sunday, hoping to clear some stuff up for you. I think I'm good from here to over here on the board. Let me just double check for you that I got those two gaps in. Awesome. So I should be able to get you anything inside this area. So this is for the quadratics unit that we've just finished up. And I feel like there was some major glitches that happened on it. So again, first off, quadratics, that's studying anything that deal with a parabola. Could be this parabola, it could be this parabola, whatever it is with it. And there was a bunch of critical points for it, and we talked about finding vertices for it, or the vertexes for it, finding the x-intercepts and y-intercepts. But I feel like there's a big issue with a couple things. One, there's got to be a difference between this, what we call multiplying, this factoring, and this solving. These are kind of our big four for this unit, and then being able to use our graphing calculators, or being able to solve by graphing. So I'm going to start off with the basic stuff. So when I multiply things together, if I had something like this, 3x plus 6 times 2x minus 7, then I'm taking that expression and I'm trying to take two smaller expressions and make them a bigger expression. When I do this, we do a thing called FOIL, which means I multiply the first thing to the first thing. So 3x times 2x, that'd be a 6x squared. And then I do the 3x to the negative 7. So I distribute the 3x to the first thing and then the 3x to the second thing. When I do that, I have to look at their signs. This one's positive and this one's negative. So that's negative 21x. And then I'm done with the 3x to both of those. So now I have to do the 6 to both of those things. So 6 times 2x is 12x. And 6 times negative 7 is negative 42. So when I'm doing this, I oftentimes get two middle terms that are the same, especially if this is a linear and this is a constant. So I'm just going to put these things together so that I get 6x squared, that's this term. Negative 21 plus 12 is negative 9x, and then of course minus 42. Okay, so that's multiplying polynomials together, in this case binomials, because bi means two. Now factoring was another thing that we asked you guys to be able to do. Factoring basically goes from here back this way. So in other words, when I factor, I'm looking to take a big part and break it up into smaller parts. So when I'm doing factoring, it could be something as basic as this. If I had 4x minus 20, I could take this expression and I could break it up into 4 times whatever's left over here, in this case, x minus 5. Because I divided this term by 4, which was common to it, and this term by 4, which was common to it. And you can always tell if you did it right, because then you can multiply this 4 back into here. I get 4x, 4 times negative 5, and that's negative 20. So when we're talking about factoring, we're talking about taking something big and breaking it into its parts. Okay, now the other factoring we did, and this was called factoring like a dentist, or factoring out the GCF, the greatest common factor. So that's what we talked about with this. The other factoring is if I had a trinomial, so like x squared minus 7x plus 10, and you can see there's no GCF, there's no number that goes into all three of these terms. I had several people that pulled an x out on the test, and yes, x is common here, and x is common here, but there's no x here, so I can't pull an x out of all of these things. So if I have this and I'm factoring it, again, we're trying to break it into two or more things that multiply together to get that expression. So in this case, if I did this, I'm looking for numbers that multiply together to get 10, which is 1 and 10 and 2 and 5, and add together to get -7, well, that just means that these two get me a 7, and I need their signs to be negative. So x minus 5 and x minus 2. So if I was asking you to factor a trinomial, this would be its factors, and you're done. That's what factoring means. Writing something down as a product of its smaller parts. And if I multiply these back together, I should get what I started with right there. Okay? So, one more time. Multiplying, taking parts, putting them together to make a whole, factoring, either what I had before with the GCF, or factoring like a dentist, as I called it, or factoring trinomials, taking a whole and breaking it into its parts. Okay? Now, I'm going to erase both of these things, and I'm going to get to what happened on your tests was this third thing, this solving thing. So solving an equation means finding a value for a variable, in most cases x, that makes the equation true. Okay? So multiplying just gives me a new expression, a bigger expression of smaller parts. Factoring takes an expression that's big and breaks it into its parts. But solving an equation means that I'm trying to find a value for x that makes it true. So when I finish this, I'm going to have an expression. When I finish this, I'm going to have an expression. When I finish this, I need to have x equals and some values. And we solved quadratic equations like 5 different ways. So I'm going to go through the first way that we use for solving a quadratic equation, or one of the ways. So 1, if I had x squared plus 6x plus 8 equals 0, and I ask you to solve this by way of factoring, solve by factoring. In the end, I still need to have an answer that's x equals, and because it's a parabola, I should have 2 different answers, right? So I should have x equals a certain number here and a certain number here, because the parabola's branches go up, and they probably hit twice. And if they don't hit at all, remember that's where we get imaginary numbers. Okay, so solving by factoring. I simply factor it, x plus 2 and x plus 4, and I set it equal to 0. So what this means is that either this expression inside these parentheses has to equal 0, or this one has to equal 0, because the only way I can multiply 2 numbers together and have them equal 0 is if one or both of them are zeros. So in this case, -2 would make this sum in this parentheses equal 0, and then 0 times, when I plug -2 into here, because I have to plug -2 into both places, right? It's x. 0 times 2 is still 0, so -2 works. And -4 works. So my answers that I want on my test, or on my homework, on my paper, whatever, are the values for x that solve this equation. And what does that mean? That means I could take -4, plug it into here, which is 16, -4, plug it into here, which is -24. 16 and 8 is 24, so 24 minus 24 equals 0. And that would work for -2 also. And I know that I showed you on this before, and it might be a little close, I'm not really sure what it looks like. But we can always store whatever our value is into our x key, right? Store it into our x key, and then we just retype the expression. So I think I said it, I don't know how many times, probably 40, 50 times. Make sure you use that and things will work out better for you. Okay, so this was solved by factoring. I'm going to erase this now, but I do want you to remember it's solved by factoring. Okay? So now I'm going to change factoring. I'm going to do this solved by CTS. Awesome. So solve by completing the square. So now I've got something like this, x squared plus 10x plus 2 equals 0. Now I cannot solve this one by factoring because there's no factors of 2, 1 and 2, that add up to 10. So I can't just factor it. So now I have to have something else. And I could have used quadratic formula over here. Not going to do that one right now. So I'm going to solve this by completing the square. When I do that, I take my constant term and I move that to the other side of the equation. So now I got a negative 2. Then right over here, I need to find a number that completes this perfect square. Well, all that number is always half of this term, which I tell you to put in a little square box, 5. And then we square the number over there. So half this term squared. So I'm going to add 25 to my equation. Well, if this is my teeter-totter's fulcrum, right? If I add 25 to this side of the equation, I have to add 25 to that side of the equation. Okay? But what I've just done is I've made this a perfect square because it is factorable into x plus 5 and x plus 5, or two numbers that multiply together to equal a trinomial. If they're the same things, we call that a perfect square. Now, if I have x plus 5 times x plus 5, I can write that as x plus 5 squared. Over here, negative 2 plus 25 equals 23. Now, it's at this time, since I have this all squared, I can just use basic algebra skills. So I'm going to square root. So then I get x plus 5 equals plus or minus the square root of 23. 23 doesn't break down nice or evenly or anything like that. So I'm just going to leave it by this. Oh, wait. I'm solving, right? I don't have x by itself yet. I'm close. Close. But I got to get x by itself. So that means I got to get rid of this plus 5. So, of course, I minus 5. So I'm going to have, if I minus 5 this side, I got to minus 5 this side. So I got x equals negative 5 plus the square root of 23 and negative 5 minus the square root of 23. And that's solved by completing the square. By completing or making a perfect square so that you can group it, two identical terms squared, and then just use algebra to square root. Okay? But again, I'm solving, so my final answer has to be x equals and these things. Now, if I took my handy dandy little calculator and I plugged in negative 5 plus square root of 23 and hit enter under storing of x, so store x, enter, then I could retype x squared plus 10x plus 2, and it would substitute that value in for x, and it would work out for me. Okay. So that's solved by completing the square. And that was x squared plus 10x plus 2. So I might as well do this one. X squared plus 10x plus 2 equals 0. Again, these are equations, right? Equations. So now instead of solving by CTS, I'm going to solve by quadratic formula. So I'm going to use that thing over there. So my A is equal to 1, my B is equal to 10, my C is equal to 2. And again, I can only use quadratic formula when the equation set equal to 0. If it's not set equal to 0, I got to move everything over to the other side. Okay, so here we go. Negative 10 plus or minus the square root of b squared, 100, minus 4 times 1 times 2, all over 2 times 1. And you're like, that doesn't look anything like my last answer. But let me finish it off. So I got negative 10 plus or minus the square root. 4 times 2 is 8. So 100 minus 8 is 92 all over 2. Okay? So I'm going to break the 92 down, simplifying radical stuff. That's 2 times 46, and the 46 is 2 times 20. Oh, 2 times 23. That's what I had before. Here are my twin 2's. So I have the square root of 92 being equal to 2 square roots of 23, right? Because technically, 2 times 2 is 4, so I'd have the square root of 4 times the square root of 23, right? Square root of 4 times square root. But the square root of 4 is a perfect square. I can just write that as 2, right? Square root of 4 becomes 2. 2 times the square root of 23. So I can erase this, and I can replace it with 2 square roots of 23. Now, the 2 can go evenly into this and into this. So negative 10 over 2 is negative 5. 2 over 2 is 1. So I got negative 5 plus or minus the square root of 23. The same answer that I got when I did my completing the square. Okay, so now I've done factoring, I've done completing the square, I've done quadratic formula, but every time when I'm done, those are solutions for x, values that make this equation true. Okay, so let's move on to another one. A fourth thing I ask you to do is just solve by algebra, solve by using square roots. So I had something like this, 3x plus 4 squared equals, I'm not even sure what I had here. Let's do 108. 108, that'd be a great one. 108. And this was solved by square roots. And this is where I just, maybe it's me, I just assumed that it would be something that we knew. And evidently, this whole PEMDAS thing is still confusing for people. PEMDAS, please excuse my dear Aunt Sally, which means I have to do operations in parentheses first, exponent second, multiplication and division third, and addition and subtraction fourth. That's the order in which I have to do it when I'm evaluating an expression. But I'm solving, and when we're solving, we have to undo it, which means I gotta go backwards on this thing, okay? So if I'm going backwards, I have to deal with addition and subtraction, but I can't deal with this addition and subtraction because this is in parentheses, which is way over there. So my next thing is I have to deal with multiplication or division. Well, this 3 is being multiplied, and I had a whole bunch of people try and distribute this 3 into here. I can't do that. I'm slapping Aunt Sally again. I can't do that because this parentheses has an exponent, and exponents come here. So I have to undo this multiplication division. I cannot distribute that in. No bueno. Can't do it. So I'm going to divide by 3. That should be my first step. I have to undo stuff. So then I have x plus 4 equals 108 divided by 3 is 36. Okay, so now I have x plus 4 squared is equal to 36. Okay, so I square root, and I square root. And I get x plus 4 equals plus or minus 6. I'm still trying to get x by itself. X is not alone, so I need x equals, and I have to subtract the 4 to get to the other side. So I got negative 4 plus 6 and negative 4 minus 6. Well, negative 4 plus 6 is 2. Negative 4 minus 6 is negative 10. So those are my solutions. X is equal to 2 and negative 10. Sound good? But wait. How do I know? Let's try it. Let's try 2. 2 plus 4 is 6. 6 squared is 36. 36 times 3, 108. Check. Let's try negative 10. Negative 10 plus 4, negative 6. Negative 6 times negative 6 is 36. 36 times 3 is 108. That works. Okay? So, we've done all of these things, and then I had two more problems that I asked you to do by choice. One of them happened to look something like this. I don't know, 3x squared minus 10x equals, I don't know, it's like this, 42. And I said do it by choice. And I feel like, and I know that you're not trying to do this intentionally, it's just we don't know it enough, right? We didn't practice enough, didn't make the connections enough, and I'm trying to help you make the connections. If I give you choice, and we have this as an option, do it. That is your go-to money thing. We have technology, right? I've talked to people in class before. Most of you got to school here by way of an automobile. If somebody lives 8 miles away, they're not going to walk to school, right? It's just not, it's not efficient. So if I have something like this and I give you a choice, use your technology for that choice. Now this is what I would do. I would take this and put it in y1. I would take this and put it in y2. And what is this? This is a parabola. This is a horizontal line. And all you have to do is second, trace, number 5, enter, enter, enter. And you get both of those solutions just simply by finding one and then getting the cursor closer to the other one. Again, I'm not sure why we didn't do that, except for that we're just not making the connections enough. So I'm hoping this video is going to help you make the connections better. Okay? And just, you could stop the video right now, try it on your calculator, just like I hope you've taken really, really good notes on this stuff. But that's all that you would need to do. So again, I'm going to show you right here. I'll go on, and this might be a little weird. We'll give it a shot here. So I'm going to put the calculator, yeah, we can do it like that. So I'm going to put the calculator here, and I'm going to go, okay. So in my y equals, I got 3x squared minus 10x. And then down here, I'm going to put 42, okay? Well, I know that this is a parabola, and I know that that's 42. So on my window, whoa, big window. Let's just go zoom 6 so that everybody has the same viewing window. So you can see I got the parabola, right? But I need to see way up higher at 42, and this only goes to 10. So on my window, I'm going to go to y max, and I'm going to go to 60. You're like, Mr. Bells, why didn't you just go to 42? Well, I don't like to see the line at the top of my screen. So now I'm going to go ahead and hit graph, and there's my parabola, and there's my red line, second, trace, number 5, enter, enter, enter. And there's one of my solutions. That's the value that is now stored in X on my home screen. So it's negative 2.429. So watch, if I go to my home screen and I type in X, there's my negative 2.429. That's one of the solutions to this problem. Okay? And you can do the other one, right? Second trace, number 5. Move your cursor over here. Whoosh. Move your cursor over here. Enter, enter, enter. And it finds the other one, 5.762. Okay. So hopefully this has now helped you understand a little bit better on some of these things. So again, multiplying takes two things, put them together, make a bigger thing. Factoring takes a bigger thing and breaks them apart. Factoring like a dentist or factoring regular trinomials. Solving equations, in this case quadratic equations, multiple different ways. By factoring if you can, so easy. Completing the square, quadratic formula, factoring algebraically. And then our last one, graphing, just simply take any of the equations and put one in y1 and one in y2. Okay? Now, we also had some application problems. And whoa, I really thought that we were just amazing with these application problems. So let's take something like this. H equals negative 16t squared plus 142t. Let me do the same lowercase t because it's just time. plus 21. And if I was to graph this, it has a y-intercept of 21, so someplace way down there, we'll call that 21. This is force of gravity on Earth. This is initial velocity, 142 feet per second, which means my parabola is going to go up here, something like this. This axis is time, and this is height. Okay, so what do we know? I need to get a window that goes kind of high. Don't have to go very far because this is just time, right? Time going across, this is seconds. So like 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6, 7, right? It's not gonna be in the air forever, right? Gravity is too powerful, it keeps sucking it down. But some of the things that I would know is what's its initial height? Well, that's when time is 0, those two things disappear, that's its initial height. This right here has a t comma y value, or t comma, I guess I should use h right here, t comma h value. So this is the time when it gets to this height. But I ask you two questions. I ask you, like, how high does it go? Well, if I'm asking you how high it goes, that's the y value at the vertex, how high it goes, or the height. If I ask you how long it was in the air, it's in the air here, but it's also in the air here, 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 and here. I got a lot of people that gave me this answer for how long it's in the air. No, that question would be, how long was it in the air to get to its highest point? Not how long is it in the air. So how long is it in the air? It's in the air until it goes right there. And of course, this should give you a t value that you want, the time that we want when it hits the ground. And the height should now be 0 because it hit the ground, okay? So on these ones, just make sure that you know what you're answering on those. And this is all about the graph. So this one, I do a maximum, right? Left bound, right bound, maximum. This one right down here, I would also graph, in my other equation, I would graph y equals 0, so I have this line come across, and then I could just do this intersection down here. And again, I have other videos that show that, but this stuff was I guess the basis of all the things that I feel like a lot of people were still confused on. I don't want to pull out people's tests and show you the stuff that they did, but I'm hoping this video clears it up a little bit more. And again, please take notes on it. I think I'm going to leave a practice sheet for you to try these things now, that maybe we can offset some of those bombed out test scores that I saw from it. Do know that I still had people that got A's on this test too. So if you're missing some stuff, again, we just need to get you there faster. And I'll try and get you more focused, and you got to put in a little bit more work. Like I said, come in and get extra help if you need it. Mr. Bells, hoping this helps.